Going to continue variable sequencings and rules that we've been talking about. This is lesson 3.3.2. In lesson 3.2, you can explore sequencing involving numbers, symbols, and shapes. Consider the following sequence: stage 1, 2, 3, and 4. The toothpick sequence can be represented by the following numerical sequence. Make a table is a good way to study the relationship between two quantities. This table shows the stage number and the number of toothpicks for the first 5 stages. You can sometimes write a rule to show how two variables are related. Here's one possible rule for the number of toothpicks to the stage. The number of toothpicks equals 3 times the stage number plus 1. That's because in stage 1 there were 4 total toothpicks. 3 times 1 plus 1 does equal 4. We're going to look at that as we move forward. Again, we have our stages at the top. For the following parts, we're going to make tables to show values of the given variables. For the first 4 stages of the toothpick sequencing shown above, the first table has been started for you. You have the stage number and the number of squares. Well, in stage 1, there's 1 square. In stage 2, there's 2 squares. In stage 3, there's 3 squares. And in stage 4, there's 4 squares. Now, how many vertical toothpicks do we have? Remember, vertical goes up and down. So in stage 1, you have 1, 2. You can count them. So I have 2. In stage 3, I have 1, 2, 3. In stage 3, I have 1, 2, 3, 4. And in stage 4, I have 1, 2, 3, 4, 5. What about horizontal toothpick? Well, let's go ahead and look at that. How many do I have in stage 1? Well, remember, let's go ahead and bring that down so we can see it on our page. I'll go ahead and bring these boxes down here so we can see them as I move up. For stage number 1, how many horizontal toothpicks do I have? That's going across. I have 1, 2. In stage 2, I have 1, 2, 3, 4. In stage 3, I have 1, 2, 3, 4, 5, 6. And in stage 4, I have 1, 2, 3, 4, 5, 6, 7, 8. That way we're filling out our tables. Now, using that information that we just completed, the number of squares. We need to find the relationship between all this. So let's write a rule to describe the relationship. Well, if you look at the first one that we just completed, the numbers of squares equals the stage number that we're in. So that's the stage number. The number of vertical lines that we have would be the stage number that we're in plus 1. And then for the horizontal lines, it would be the stage number that the boxes are in plus 2. I'm sorry, not plus 2, times 2. Let me go ahead and make that clearer. That's times 2. So go back to your boxes, look and see if that works. Stage number is the same. Stage number plus 1 gives us vertical. And we said stage number times 2 gives us horizontal. Is that correct? If you test it, it works every time. Now, to check that rule, you can test them for a particular stage number. Although this will not tell you for certain that the rule is correct, it is a good way to find mistakes. For each part of exercise 2, use your rule to predict the value of the variable of stage 5. Then draw stage 5. Picture. Check your predictions. Well, if the number of squares is the stage number, in stage 5, I should have 5 squares. If I was going to draw that picture, I can go ahead and I can draw out 5 squares. All right? Remember, in the picture that we had, they're connected, which I should have done. So let me go ahead and rewrite those just to help you visualize it a little bit more. 5 squares being connected, you would be done like this. 1, 2, 3, 4, 5. Now, the number of vertical lines. Well, I just said that the rule was the stage number plus 1. So that means I should have 6. Let's go ahead and check that. Here's 1, 2, 3, 4, 5, 6. Yes, that's correct. The number of horizontal lines, I said the rule was the stage number times 2. Well, if the stage number is 5 times 2, it should be 10. Let's go ahead and check that one as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, that checks out. Now, as you have seen, letters are often used to represent variables. For example, consider this rule. The number of toothpicks equals 3 times the stage number plus 1. If you use N to represent the stage number and the letter T to represent the number of toothpicks, you can write the rule as follows. T equals 3 times N plus 1. The rule is shorter than the original one. That's a little easier to write. You could also write it as T equals 3n plus 1. Because remember, a number next to a variable means to multiply. When a number is multiplied by a variable, the multiplication symbol is often not shown, just like I showed you. Here it is written and typed out. Here's another way you could write it. You can use any letter to represent a variable, as long as you say what the letter represents. For example, you could use W to represent the stage number and Z to represent the number of toothpicks, and write the rule as Z equals 3W plus 1. It means the same thing as T equals 3N plus 1, as long as we say what those variables represent. Here's a bunch of other ways to write a rule. A single rule, it can be written in many ways. Here are 6 different ways to write the same rule, T equals N times 3 plus 1. The rules above need parentheses because the order of operation states to multiply before you add. However, it is not incorrect to include them. So if we put the parentheses, fine. If we didn't, that's fine too. We're going to get the same answers. Now, let's rewrite your rule from exercise 2 in a short form by using N for the stage numbers and a different letter to represent the variables. Remember, you can pick any letter that you would like to pick, and we can determine what that's going to be. So what would be the variable for the number of squares? Well, I'm going to say the variable for the number of squares is S. If the stage number variable is N, then N has to equal S, because we already said that the number of squares equals the stage number. Let's say I want a variable for the number of vertical toothpicks. Well, I'm going to use the variable V, because it represents vertical. And for our rule, we said that it is the stage number plus 1 equals the vertical toothpicks. And then for the horizontal toothpicks, I'm going to choose H. And in our rule that we had, we said the number of horizontal toothpicks is equal to 2 times the stage number. Or I could say 2 times N. 2n, because it's the stage number. So consider this toothpick sequence. Here we have, choose a variable other than the stage number. So if I wanted to choose a variable, I can choose any variable that I would like. Let's say I'm going to choose T. That's going to be my variable. Now create a table showing the values of your variable for each stage. My variable is T. To find a rule, though, we've got to kind of complete that table first. So what's my T going to represent? Well, I'm going to say that my T is going to represent the total number of, let's say, horizontal lines. So if in stage 1, if N represents the stage number, how many horizontal lines do I have? I have 1, 2. How many do I have in stage 3? 1, 2, 3, 4, 5. How many in stage 3? 1, 2, 3, 4, 5, 6, 7, 8. What would I have in stage 4? Well, to do that, I kind of need to figure a rule or start looking for a pattern. Well, the numbers are in order for the stages, so I can try to find the difference. What happened from 2 to 5? We increased by 3. That goes with my variable. So my variable for my stage numbers is n. So that would be 3n. If I substitute 1 in for n, I have 3 times 1 is 3. What do I have to do? How do I adjust it to get to the total number 2? I have to subtract 1 equals my t. That would be the rule for that one. Now I could go ahead and find out what 4 would be. Substitute 4 in for n. 3 times 4 minus 1. What does that equal? Well, that equals 11. Now, what if I had triangles? Again, choose the variable other than the stage number. Well, let's say we're going to use the variable s. Doesn't matter what variable I use. I'm going to use s, and s is going to equal the slanted lines. Remember, as long as I identify what it stands for, I can use any letter. So if s is going to be the variable that I choose, create the table. Well, in stage 1, how many slanted lines do I have? I have 1, 2. In stage 2, how many do I have? 1, 2, 3. In stage 3, in stage 3, how many do you have? 1, 2, 3, 4. And in stage 4, how many do I have? If I count them, I have 1, 2, 3, 4, 5 of them. Now, try to find a rule that connects the stage number and my variable. Well, I said my variable represents the slanted lines. So what could be a rule I could write? Well, if you look at the change from stage 1 to stage 2, it went from 2 to 3. It only increased by 1, so that's my n. What do I do if I put 1 in for n to make it equal 2? I have to add 1 to equal the number of slanted lines. So what that represents is the number of slanted lines is the stage number plus 1. Now we have some dots. Choose a variable. Well, I'm going to choose D, and it's going to represent the total dots. Remember, I have to justify what it is. So I'm going to choose a variable D, and it's going to represent the total number of dots. So in stage 1, how many dots do I have? I have 1. In stage 2, I have 3. In stage 3, I have 5. And in stage 4, I have 7. Now, what would be the rule for this? Well, again, what is the change from stage 1 to stage 2 in the bottom? It's 2. That means 2 goes with the variable n. What do I do when I substitute 1 in for n? I have 2 times 1 equals 2. I have to make it equal the 1, so I have to subtract 1 to make it equal 1, the variable for D. Now consider this rule. T equals 4 times n plus 2, where n represents the stage number and t represents the number of toothpicks in the sequence. Write the first 4 numbers of the sequence. Well, first we got to understand that the first 4 numbers are the first 4 stages. So if this is stage 1, this is stage 2, stage 3, and stage 4. Remember, n represents the stages. So if I substitute 1 in for n, 4 times 1 is 4 plus 2 is 6 to give me t, the total number of toothpicks. Put in 2. 4 times 2 is 8 plus 2 is 10. Substitute in 3. Remember, that's 4 times 3 plus 2. What does that equal? It equals 14. And then put in 4 for n. 4 times 4 is 16 plus 2 is 18. And then you can draw your pictures. In stage 1, you'd have to draw a picture that would show 6 boxes. And you could draw them however you wanted to, as long as you get 6. 1, 2, 3, 4, 5, 6. And you continue to draw stage 2, stage 3, and stage 4. I'm not going to draw those all out for you, but you can do those in your notes. Now consider this rule. D equals 3 times parentheses n plus 1. N is representing the stage number, and D represents the number of dots in each sequence. Again, remember we have stage 1, stage 2, stage 3, and stage 4. And we're substituting in the stage number, which represented n, for the n in the rule. So 3 times 1 plus 1. Well, I have to do parentheses first. So if I have 3 times 1 plus 1, substituting in 1, what does that give me? That gives me 3 times 2, which equals 6. Again, substitute 2 in for n. Why, first you have to do parentheses. So 2 plus 1 is 3, times 3 is 9. Put in 3. 3 in for n. 3 plus 1 is 4, times 3 is 12. Now put in 4. 4 plus 1 is 5, times 3 is 15. And then draw your picture. You can do stage 1 and draw out 6 dots. You can draw this. I'm not going to draw them all. Now, draw a toothpick or a dot sequence. Make your sequence change in the predictable way. Name 2 variables for your sequence. For each variable you named, try to write a rule related to the stage number to the variables. Use letters to represent the variables, but tell what the letters represent. Well, the first variable I'm going to have is n, which equals the stage number. The second variable I'm going to use is m, which is going to equal the total. Dots. I'm going to use dots for mine. So let's draw a picture here to show what I want to do. So if I'm going to draw my picture, I'm going to draw it up top here for stage 1. I'm going to draw a picture that has 5 dots. For stage 2, I'm going to draw a picture that has 7 dots. Stage 3, I'll draw a picture with 9 dots. And for stage 4, I'll draw a picture which says has 11 dots. 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, those are my 4 stages that I just drew my picture for. Now, write a rule. If you can't see it without making your table, go ahead and make one. 1, 2, 3, 4 for the stages, and make yourself a table. Here's N, here's M. In the first stage, I had 5 dots. Second stage was 2. Stage 2 was 7. Stage 3 was 9, and stage 4 was 11. What's the rule? Well, the rule for variable 1, which is n, the stage number, is n plus 1, because the stage numbers keep increasing. That's what I said variable 1 meant. The rule for m was to get to the total. So in this case, I have to find the change. So that means 2 times the stage, because it changed by 2 from 5 to 7. If I substitute in 1 for 2, 2 times 1 is 2. I have to add 3. Let's go ahead and give our homework a shot. It is pages 12 and 13.